everyone, I'm Akif, and today we're going to discuss about TCP. In the previous video we discussed about UDP and its various limitations and features. Today we're going to discuss TCP in detail. So just like UDP, TCP is a transport layer protocol, and TCP is a connection-oriented and reliable transport layer protocol. And to understand connection-oriented, what does connection-oriented mean? I gave an example in the previous video of UDP, where a guy wants to contact his friend and he is calling him. A dial tone is there, and once the call gets established, they are able to communicate with one another. So TCP is connection oriented, unlike UDP. And how connection is established, we will discuss it in detail. It's called as three-way handshaking. TCP is a reliable transport layer protocol. What does one mean by that? In UDP, what we understood is that there is no acknowledgement. What happens to the letter in the middle, whether he receives it or doesn't receive it, no one knows about that. That is the unreliability part in UDP. However, in TCP, when a guy is sending a letter, he gets an acknowledgement that, thanks John, I got it. He receives, and whatever happens to the letter, he comes to know about it. So this is the reliability part, that you have an acknowledgement in TCP. You don't have to worry what happens to the letter. Even if something bad happens to it, you are provided this information about it. That's what reliability in TCP means. Now, TCP provides reliable service with the help of sequence number, acknowledgement number, flags, and timers. Now, all these will be discussed in detail, where we have this thing called sequence number. Sequence number is where when a TCP packet is sent, it's called a segment, and this data is coming from the application layer, and it is arranged in small segments. And the first bit in that segment is given this number. It's called sequence number. Acknowledgement is, as understood, when you receive the acknowledgement that whatever happened to the packet. Flags, there are various flag bits which we will discuss in detail, and there are timers. And timer is something when you send the packet or segment, you set a clock here. You set a clock and you set a time. For example, for the sake of example, let it be 3 seconds. Within 3 seconds, if it doesn't receive acknowledgement, then it is sent again. So this is what timer is for. Now, in case of UDP, we came to realize that sometimes packets will be received which are duplicated. Sometimes packets may be missing and they are not ordered. We saw in the example where this friend John was sending letter to Sam, and Sam received something that was too difficult to understand. It didn't mean anything. Everything was disordered. Now, what happens in TCP is that, suppose you are sending your data. This is your side and this is your friend's side. In the middle there are various paths to your friend's computer. So what happens if you have sent these packets in this order? 1, 2, 3, 4. Suppose 3 and 4 goes this way and they reach first, just like this, 3, 4. And then you have 2 going this way and 1 going this way. Suppose 1 reaches first, 3, 1, 3, 4, 1, and then it's 2. So it is completely unordered. But in TCP we have this reordering mechanism. It sets and reorders it into the exact order in which they were sent, 1, 2, 3, and 4. So you receive a letter that is completely ordered, just like this. Whatever was sent is received. So that is what ordering means in TCP. We also discussed in UDP that there is no flow control mechanism. there is no way to let the sending machine know that the destination machine cannot cope up with the amount of data you are sending. There was no readjusting factor in that. But in TCP, we have something called as windowing concept, where depending upon the amount of resources available on the receiving side, it lets the sender know that you need to slow a bit. And depending upon those resources that are available on the destination side, it adjusts its window. If it was a bit bigger, it gets smaller, depending upon the amount of resources we have. So they contract and expand depending upon the amount of resources available on the destination machine. Now when you look at the format, there is this header part and data part. Header may be from the size of 20 to 60 bytes, and this is what is present in the header. And we also discussed that UDP was simple just because its header was small, and we also mentioned that the header of TCP is 60% bigger than the header of UDP. And you can have a look at this. In TCP we had this we had 4 fields. One was source port, destination port, checksum, and total length. But in this case we have many fields, and we will be discussing them in detail. So source port is used to identify the process that is running in the sending side, and it's a 16-bit. And we also discussed about the INA ports, where we have the range of availability equal to 2 raised to the power 16. So these are the number of ports that we can choose from. Similarly, on the destination side, we have the process running, and in order to identify that process, we have the 16-bit field, which is called destination port. Then we have sequence number. What is the sequence number? As I said, when the data comes from the application layer to the transport layer, it is multiplexed first. And when it's multiplexed, we have this data which is broken into chunks, and we call these chunks as packets. And when these packets are belong to TCP, they are called segments, and they are numbered. We give this number 1, we give this number 2, we give this number 3. The first bit is numbered, so that's what is called as sequence number. It's a 32-bit field. And then we have acknowledgement number. Acknowledgement number is when you receive the data. Then you, for example, if you receive packet number 5, then the acknowledgement number that is sent to it is 5 plus 1, or which is equal to 6. So this means that I am expecting 6 from your side, a packet with sequence number 6. Similarly, we have data offset. It's a 4-bit field, and as I said that the header of this TCP IP is from 20 to 60 bytes. So this will be identified with the help of this field. Then we have reserved, which is 16-bit, and this field is used for the future use. Then we have flags. These flags are very essential for flow control, for connection establishment, connection termination, and data transfer. Then we have window field. As I said, that windowing is a concept that's used for flow control, and in case of TCP, this size, the size of the window, is adjusted depending upon the amount of resources that are available on the destination side. Then we have checksum. Checksum is something that's used for error detection, and in TCP it's mandatory. In UDP it wasn't. It was something that wasn't that much essential, but in TCP it is mandatory. The urgent pointer is used to send the urgent data, and it will be sent only when this urgent flag is equal to 1. Now we have these various flag bits. One is finish. Finish is used to terminate the connection. It's called fin. Syn is used to synchronize the or ST is used to reset the connection. Acknowledgement is used to provide the acknowledgement, and it's used to indicate that the acknowledgement is valid. Then we have urgent. Urgent is used for sending the urgent data, and it's used to indicate that urgent pointer is valid. Then push, PSH, is used for the request for push. So whenever we are sending data, we buffer it. It's used to tell the machine that you shouldn't wait for the buffer to be empty. So buffering concept in itself is another topic which we will cover in some future videos. But for now, it's not that important, or you just need to keep this in mind, that it's used to push the data and it has something to do with buffer. Now we have these two machines. One is the client side, another is the server side. And we also discussed about the socket address, where we have IP address and we have the port number. We have the IP address and port number. So that's what is on the client side. Similarly on the receiver side. Now they are trying to establish a communication with one another. So what happens is that client triggers the process, it sets the send flag, and sequence number is equal to 0. It's not always going to be 0. It can be any random number. Now to respond back, it will the server will set its acknowledgement number equal to 1, which means that the next packet that I am expecting should have the sequence number 1, and at the same time it's setting its SYN bit, and sequence number is equal to 0. So it can also be any random number. So it's also trying to establish communication from his side. Maybe he has to send the data, just like client is ready to send the data. Similarly, to send the data from the server side, it is setting its sequence number equal to 0. Now what happens is that the sequence number of the client, as it was 0, will change to 1 because server is expecting 1, and similarly it will send the acknowledgement to server, which is equal to 1. So the acknowledgement 1 means that I am expecting a packet of sequence number 1 from the server side, and at the same time I am sending my own packet with sequence number 1, which actually server was expecting. Now this is called connection establishment. So once connection is established, we are ready to send the data back and forth. Now we need to keep one thing in mind, is that the very recent packet that was sent from the client had acknowledgement number 1, which means that I am expecting a packet with sequence number 1 from the server side, and at the same time client is expecting to send the acknowledgement from the server side for this packet whose sequence number is equal to 1. And once the connection is established, server is ready to send the data. It sends 100 bytes with sequence number equal to 1, and client responds with an acknowledgement number of 101, just because server had sent 100 bytes. 100 plus 1 is equal to 101. Server, on the other hand, tries to terminate the connection because this was the amount of data it wanted to send, and its sequence number is 101, which was the number the client was expecting, and it responds with an acknowledgement of 102, but this is where the server stops sending the data. And now client sets its fin bit, which is finish, with sequence number equal to 1. The only reason the sequence number is 1 here is because there was no data sent from the client side so far. Only server was sending, and client was replying back with acknowledgement. So in the previous example, when the client was and server had established the connection, the sequence number was 0, and it was expecting the acknowledgement, and the acknowledgement wasn't received yet. And now the sequence number is set to 1, acknowledgement number is provided, which is equal to 2, and acknowledgement is given back to this. Now connection is terminated from the server side, and client tries to disconnect now. It's setting its fin flag to 1, and sequence number is equal to 1. It's 1 just because the only kind of data that was moving from the client side was acknowledgement. It wasn't sending any other data. So if you look at the connection establishment process, which I discussed previously, the sequence number of client was 0. Now it's going to be 1, and acknowledgement is provided from the server side, and this marks the end of the connection between client and server. So in order to understand why this is equal to 1, is because here it was 0, over here it was 0, now here it is 1. The only data that was getting sent from the client side was acknowledgement data. It wasn't a data where flag bit was set to 1 in the SYN field. So that marks the end of connection termination. And let's now try to have a look at Wireshark. And these are the packets that I have captured in Wireshark. These are all the packets: TCP, IGMP, HTTP, DHCP, but we are interested in TCP here. So to make it much easier, we need to type in the filter TCP. So the connection establishment, in connection establishment we have something like SYN, SYN-ACK, and ACK. So that is what is called as connection establishment. You can have a look at this. So this is connection establishment, where we have something like SYN, ACK, ACK, and which is something like this. On the client side, SYN, then it is responding back with SYN, ACK, and finally ACK. So this is what is called as three-way handshaking. So let's scrutinize on various packets and look at it in much detail. Let's have a look at this packet and try to figure out what is inside it. This is 0100, so it is IP version 4, but we're not interested in that. We're interested in something over here, which is source port, destination port, then we have sequence number equal to 0, and it's saying that it's relative sequence number. Then we have header length equal to 32 bytes. As I said, it's between 20 to 60 bytes. Then what else is there? The flags SYN is set to 1. And the window size is 8192. So as I said, it depends upon the amount of resources available on the destination side. So that's the information that's contained in this packet. Now let's have a look at SYN-ACK packet. So the flags that are set over here are SYN and ACK. Header length is 32. Destination port and source port are here. 443 is on the source port. On the destination port we have 1086. Then there's source address, destination address, and there are this fragmentation information which we might cover in some other videos, and the flags that are set is SYN and ACK, and the window size is 29,200. Now let's look at this ACK. So the information contained in this is that source address, destination address, source port, destination port, sequence number is 1, flags that are set are acknowledgement ACK. What else is there? Version, it is 4, and window size is it's 16,425. And what else is there? There's checksum. This is what we understood from SYN, ACK, and ACK. Now let's try to have a look at the flow. We'll try to have a look at various TCP packets that are exchanged between source and destination. So you can have a look at this. There is this port number 1084, there's destination port number 5228. There's SYN, ACK, there's push ACK and ACK. So this is how the information is exchanged. So SYN, ACK is actually connection establishment. Then once the connection is established, there's the push flag set to 1, acknowledgement, and then length is given. There's source port and destination port. This is the source port, which is 1086. This is the destination port, which is 443. So you can have a look at various conversations going on in TCP, and this is only related to TCP IP. You will only see the fields that are present in TCP IP, like FIN, ACK, push ACK. So I suggest you to download this packet analyzer so that you can understand these packets in a much depth and detail. So that was all. Thanks for watching, and if you think that these videos were useful, press on the like button, share it, and subscribe to our channel.